Okay, so here we are. I'm going to make a key for the mole study guide. The mass in grams of 1 mole of any pure substance is called the molar mass. And I want you to look at this 1 mole, the mass of 1 mole, molar mass. Kind of a no-brainer. The number of particles in exactly 1 gram of pure substance is equal to, no, that is not true in any way. The number of particles in the molar mass of a pure substance. So let's say 12 grams of carbon is 6 or Avogadro's number. That's what they're looking for here, I think. All right. Now we got some molar masses to add up. So calcium, I have 3 of them. They weigh 40 each. So 3 times 40, enter, and then what am I going to add to it? I'm going to add 2 phosphoruses, which is 31 apiece, so that's 62. So I'm going to add plus 62 here. And then we've got 8 oxygens. So I'm going to add 8 times 16 oxygens. And I get 310 grams per mole. Don't forget those units, they're important. Okay, CuSO4. So I have copper weighing in at 63.54. And I only have 1 of those. And I have 1 sulfur, which weighs 32. These are all off the periodic table, by the way. Plus, and I have 4 oxygens. 4 times 16, 159.54 grams per mole. CaCl2, so I have 2 chlorines at 35.45 apiece. And I'm going to add a calcium, which weighs 40. It's 110.9. I guess I should probably grab the periodic table, but I'm hoping everybody knows this by now. So when we're doing a molar mass, we're just adding up everything in here. So we have a carbon, which weighs 12, plus 2 oxygens that weigh 16 apiece. So it's 12 plus 16 plus 16, so 32, 44. Is that right? Did I do that right in my head? 30, 42, yeah, 44. Yep, I did. And silicon, which is a pure substance, so 28.1 grams. And in 28.1 grams of silicon, there are Avogadro's number, or 6.02 times 10 to the 23rd particles. All right, so they've given us grams, and they want us to go to moles, and then they want us to go to particles. So I'm going to need some more paper. Okay, we're on the back of here. So we have to go from 2.5 grams of Ca3PO4 2. I'm going to pull this over here, move the camera a little bit. So each one of these is going to require a few calculations. And then we need to go to moles. Everything has to go from grams to moles and then to particles. You can't go from grams to particles. You have to go 1, 2, 3. All right. 2.1 grams, 310 grams a mole, grams per mole, and 1. Oops. Yeah, sorry. Let's just leave it at grams there. I mean, you can put grams per mole, because all that's going to be left is, all right. And 1 mole equals 2.5 grams of Ca3PO42. So we have 2.5 grams. Remember, we multiply by everything on top, which by 1 is itself, and divide by everything on bottom. 310. So what I get is 0.008065 moles. And then we're going to convert that to particles. So in 0.008065 moles. Down here it has to be moles. They want our answer in particles. Particles. I only know one relationship between moles and particles, and that is in 1 mole, 6.02 times 10 to the 23rd particles exist. You noticing that you put 1 mole on everything? Okay, times times 6.02 times 10 to the 23rd, and I get 4.85 times 10 to the 21st particles. Okay, so 0.008065 moles, 4.85 times 10 to the 21st particles, atoms, whatever you want to call it. Notice how they lump them all in together here: particles, atoms, molecules, formula units, whatever. Okay, and now we have moles, and we have to go to grams, and moles, and we have to go to particles. So this is fairly easy. 16.3 moles. We're going to go to particles first. So 1 mole. Oops. Sorry. Let's just move this down a little bit. 16.3 moles of CuSO4. It's going to become important to do that. Write down exactly what your units are of. And we want to go to particles, so we're going to go atoms. And in 1 mole, there are 6.02 times 10 to the 23rd atoms. So 16.3 times 6.02 times 10 to the 23rd is 9.81 times 10 to the 24th atoms. And then we got to go from moles to grams. So we go 16.3 moles CuSO4, 1 mole CuSO4. That's how many grams of CuSO4? 159.54. And so 16.3 times 159.54, 2600.5 grams. Grams CuSO4. See, it's not just your pencils I break, it's my pencils too. Okay, so what did we say? We said 2600.5 grams CuSO4. Okay, CaCl2, and they give us the molecules. We have to go from molecules to moles, and then from moles to atoms. Okay, and they give us 9.44 times 10 to the 23rd atoms. And we are going to moles, atoms. And again, the only relationship I know is if 1 mole is 6.02 times 10 to the 23rd. If you ever get something, because I've seen a lot of y'all want to reverse this. You want to put 1 atom equals 6.02 times 10 to the 23rd moles. And I want you to think about what a mole is. In 12 grams of carbon, is there 1 atom? No, almost certainly not. If you're getting atom counts that don't have 23 zeros, if they don't have this, does that seem realistic? Because even in the tiniest little speck, in this speck, there are millions of atoms. So if you ever find yourself putting 1 atom on anything, please correct that. It is not true. All right, 9.44 times 10 to the 23rd divided by parentheses 6.02 times 10 to the 23rd. I get 1.568 moles. What am I looking at here? CaCl2. 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 And then we got to go from moles. 1.568 moles. CaCl2. 2 grams. CaCl2. 1 mole. CaCl2 equals. And what is the molar mass of CaCl2? It is 110.9. So I have 1.568 times 110.9 gives me 173.9 grams CaCl2. All right, so CaCl2 in grams, I have 173.9. In moles, I have 1.568. All right. Since this video is getting a little long, I'm going to stop this thing and start into section 2. And I'm just going to keep going. I'm going to work this whole thing out. All right.